The question that I hear the most when it comes to green energy from my friends is without a doubt, should I invest into green energy now or should I wait for energy prices to go up and take the plunge? The second question usually following is, Kareem, did your investment pay off? I'd say the challenge with those two questions is that they ask for a binary yes, no type of answer. The reality is that investing in solar panels, electric vehicles, or batteries is expensive and must be looked at from a long-term investment perspective. It is therefore crucial for homeowners to be able to not only be able to measure but also predict the future benefits of their investment. As Edward Deming said, without data, you are just another person with an opinion. Learning how to measure the benefits of any investment in your home must therefore be your first step, as it will influence the specifications of the solution you will purchase and its acceptable budget. Let's take an example. If you can predict that in 5 years you should be able to save $30,000 or pounds in energy cost by installing solar panels and using an electric car, this data point will have a significant impact on your decisions and your plans. It is therefore extremely important to first decide what criteria and metrics you want to improve. In this channel, we introduce the concept of the Smart Sustainable Journey and the 3 objectives of the Smart Sustainable Home, which are first, to improve sustainability, such as reducing CO2, 2, improve the quality of life of your family, and 3, finally, save money. In case you missed those, you will find the links to those videos here, and I will add a link to those videos also in the descriptions. All 3 objectives listed in this diagram can be measured, even the quality of life. Now, to be honest, yes, there are metrics to measure the quality of life of nations, which include access to drinkable water, crime rates, amongst many others. Now, fortunately, crime rate in my home and family is decently low, and access to drinkable water is not an issue. I will therefore focus on the other 2 objectives. Let's get started. The first suggestion I hear is typically that those data points should be easy to get. If I already have a green energy generation solution such as solar panels, I should be able to leverage the reporting from the inverter. Now, the inverter is a device that will convert direct current from the sources such as solar panels and transform them into alternating current used by appliances in our homes. Most, if not all inverters nowadays produce statistics that can easily be retrieved from a mobile application or from the cloud. If you're looking at the potential solutions to purchase, make sure advanced reporting from mobile applications and cloud dashboards are features your solution will offer in a reliable manner. At the end of the day, if my solar panels produced 10,000 kilowatt hours last year, as an example, that data point should be easy to translate to reduction of cost and greenhouse gas, such as CO2, right? Yeah, well, the reality is that to produce correct or even semi-correct data is not that easy. In this video, we will review the basic knowledge you need to measure or predict your savings in terms of money and reduction of greenhouse gas, as those 2 will be the metrics I will look at to measure my success versus the key objectives I listed for my sustainable home. One disclaimer though, you can go in a deep amount of details on the matter and be aware that there are entire companies dedicating their lives to answering that single question in great details. How deep and pedantic you want to be is entirely up to you. The objective of this video is to provide an introduction to the key dependencies and factors to keep in mind and have an educated way to measure your home energy savings and greenhouse gas savings. If you look at money savings, the basic approach described in the introduction was not far off. We just need to go into the next level of details. We need to split down the green electricity generation statistics in kilowatt hour between the main energy consumption of your home, such as heating, car transportation, and basically everything else in your home, such as lighting or television. Each energy production must then be compared to their normal cost. And again, we will need to detailed consumption reports from systems such as heating, cooling systems, car charging to complement the data from your home inverter. Again, nowadays, car chargers, inverters come with user-friendly mobile applications and cloud-based reporting dashboards. The only catch is that electricity, gasoline, heating oil price do change on a regular basis, and those variations must be also taken into account. So, whilst you can obtain periodic reports of the amount of kilowatt hours produced by your solar panels and also the amount of miles or kilometers driven by your car, getting accurate cost information over the course of 1 year is not easy. Fortunately, there are plenty of websites that keep those cost statistics for you in your country so they can fairly easily derive your annual savings. For short, you input your electricity production in a given year and you get the average price for it. You can get the average gasoline price for a given year that you can match with your internal combustion engine consumption and so on. And yes, that was the easy one. Identifying greenhouse gas savings such as CO2 savings is a little bit trickier. The reason is that electricity providers generate electricity in different ways. If possible, taking advantage of locally available natural sustainable energy sources such as sun, wind or gravity. As we can see on the Electricity Maps website, the greener the country or region, the least CO2 the electricity distributed in that region or country uses. Some countries invested in sustainable energy production, some in nuclear, and some just decided to continue generating electricity with legacy, dirtier sources such as coal. Well, what this means is that the electricity you get from the grid may already be green, clean, and solar panels will only help you save lots of money, but marginally improve the CO2 for the world. For other countries, for example, if they still burn coal to generate electricity, CO2 savings will be significant. Even more complicated, the situation and color on this picture will evolve over time. Let's have a deeper dive on the Electricity Maps website. Alright, so we are now on the electricitymaps.com website. If I click on View the Map, it will get me to this page. The Electricity Maps website in its application allows us to get better visibility into the intensity of the carbon intensity of each country electricity generation. For countries which are not in gray, so the countries in gray do not share any telemetry or data available publicly, we can see whether they're greener or darker brown. So green, as you may imagine, is low carbon intensity measured in gram CO2 equivalent per kilowatt hour, and more advanced it is in the darker areas. It means that we are generating electricity on average with fossil fuels. Let's take an example. If we take an example, let's start with Europe, for example. If you take the example of Iceland, Iceland generates almost 100% of its electricity with low carbon energy. We are primarily on geothermal and hydro. At the same time, this website, Electricity Maps, allows us to view the carbon emission, which is not zero, because we still need to distribute it and we still need to build those dams and so on. So it's not 100% electricity free, but it's actually fairly low for a country of the size we're talking about now, 20 tons of CO2, for example. As we speak. If I go to a drastically different example, Ireland is a much worse amount of carbon intensity, going from 28 grams to 565. And the reason is that on 75% of the electricity from Ireland come from burning gas, and 10% still comes from burning coal, which is kind of the worst. So if I contrast it with another country, which is France, which has decided to produce its electricity, as you can see, with a very, very low carbon intensity through nuclear. If I click on it, I will see that it's still low carbon, but it's not very renewable, meaning that the vast majority, which is 70% of electricity, comes from nuclear, and very massive production because it exports, as you can see, green energy to other countries. Yet it is not renewable, as we are still stuck with uranium after production. but still it's extremely green. Finally, let's take another example, which is Spain. Spain, another interesting country because we still partially have some nuclear, some wind, a lot of solar, to currently 36%, where in the middle of the day is coming from solar. Interestingly enough, the data provided by electricity maps is near real time, meaning that it does change over time. Specifically for solar, the electricity produced now is fairly high, so we have a fairly green on average electricity production. However, at night, there will be no more sun, and therefore the state will have to burn more gas in order to make up for the demands. So this is why the average amount of CO2 will go up during the night. So as we can see here, the amount of solar goes up, and usually the same bell curve, and at night goes to almost zero, if not zero in this case, and that's it. So if we look at the worst case of Europe, that's going to be Kosovo, and Kosovo is pretty dark because it's producing 100% of its electricity through burning coal, so it must be really polluted over there, and therefore its carbon emissions for such a small country are off the chart. If we make the same exercise on, for example, California, we will see also a fairly sharp difference. They still burn a lot of gas because I'm capturing this video at night for the US, day in Europe, and therefore you can see that as soon California will wake up and they will use their solar panels. Therefore, the amount of CO2 will go down and it will pick up back again at the end of the day when there is no more solar produced. The lessons learned of this overview is that no matter where you live, you need to understand and know where the electricity from the grid is coming from. As you could see in this example, I could install a lot of solar panels in Iceland and I would surely save money, but I will absolutely not save a lot of CO2. Whereas if on the other hand I live in Ireland, if I could install solar panels, definitely do it, because it will be very high impact on the amount of carbon savings as well as saving you money with free electricity. So let's recap what we have learned today. Step 1, you must identify all reporting tools in your home that can help you record both production of electricity for your home and consumption of energy such as gasoline or electricity, for example, your electric car, current or future, for your electric heating and others. If you are planning to buy such a solution, ensure the vendors you select offer this possibility. If the solution installed in your home does not provide statistics, well, you can still fairly cheaply and easily add connected measurement tools to provide you with the data of electricity consumed. Second step, identify all specifications required, such as CO2 emissions of your car per mile or kilometer, or its gasoline consumption in case of internal combustion engine. And finally, unless if you love details and want to spend a tremendous amount of time in Excel, leverage country or regional online reporting tools such as for CO2 or pricing. It will be sufficiently correct for you to derive the correct conclusion. In my case, I did the math for the last 6 years, which is since I installed my solar panel solution in the home I live in. I can articulate why I saved close to 12,000 euros and over 10 tons of CO2. Those numbers came primarily from my home inverter and home electric car charger statistics mapped to the fuel electricity prices in Spain, which is the country where I live. I also leveraged Spain grid operator CO2 statistics. Of course, I could have added even more details to be more accurate, would not have changed the conclusion. Finally, note that the savings have grown linearly. Starting with a modest savings the first 2 years, I used those early savings generated to add more solar panels, add thermic solar panels to generate hot water, and 2 years later also added even more solar panels to add an electric car charger. Those savings also helped my family enjoy better vacation, which I felt was also a good usage for the savings. Bottom line, based on the metrics and that matter to me, and based on the real data, I can now provide an educated answer to the original questions. Yes, I'm successful in my evolution and acceleration of my smart sustainable journey for my home. I can confirm I improved the 3 objectives positioned for the smart sustainable home based on hard evidence. Before I close, Small disclaimer again, you might have a different opinion on which metrics should be used and argue I missed data such as the CO2 required to produce electric vehicles. And again, this is perfectly fine, as you are fully allowed to build a set of metrics and measurements that work best for you. On a personal basis, I know that additional details and complexity to the formulas would not fundamentally change the conclusions of my research. As always, if you like this video, please hit the like button. And if you want to learn more about the sustainable journey, consider subscribing to the channel. Now it's your turn. Are you using different metrics, different formulas? And what are your conclusions? Let us know in the comment section below, and we will see each other in the next video.